So have you got the link? Now they have got the link. Need nothing level surface to put this.
Maybe next time we will discuss more we can use the box.
Yeah.
This itself is
Okay, so people join. We won't know whether they're joining. Huh?
I can see 4 people are watching, so or 6 are watching, but we don't actually get to know.
Okay. Are these people only or
That it does not show like unless they type something in the chat box. So
okay.
last time we had this strategy that whenever someone joins, they write their name in the chat box. So we get to know.
Yes, we'll have to tell them to do that. Yes.
There are 9. If it is a WhatsApp group or something, then it is much faster.
Yeah, I think that we will ask these people to do. So
Maybe you can actually start and you can watch it later also because the link will be there.
okay.
Uh, and
So I think I'll start. Hello, good morning everyone. This is the very first lecture of our course, which is called Foundations of But this course is really much of mathematics. Okay, we are going to do it from the point of view of scientific computing. This course is much of mathematics, and the topics which we will be doing will be functions, then derivatives, integration, series, and then differential equation. How much the board is visible? Is it visible? Hmm?
In the video, it is visible.
In the video it is visible? Yeah. Yeah. Please try to understand the situation right now that we are going to have these online classes, and because of that it is very essential that you give us the feedback of what is happening, how the writing is seen in the video and all that. Okay. So coming to the teaching of the course, we are going to cover these many topics. Always a topic will be accompanied by its applications also. Derivatives and application of derivatives, integration and application of integrations, etc. Then if you ask me the books, there is one book. There is one book, Calculus and Analytic Geometry by Thomas and Finney. This book contains almost everything and much more. But the portion is given, the syllabus as such is given in many books. You can use your 12th standard or FIPSC books if you wish to. In fact, much of the portion is common to your 11th and 12th standard textbooks. So problems you can take from that. What we will be doing will be from a little different point of view, not different but different point of view. So why do we call it foundations of scientific computing? So if I ask you one question, that what do you want to do after this? The 90% of the students will say artificial intelligence and machine learning. Okay. So what do you want to do exactly with that? How do you start? What is artificial intelligence? What is machine learning? How does the machine learn? Any idea? How does the machine learn? What is machine learning? Principally, what is done in all these things? Rough idea, I am not going to ask algorithms. What is meant by these two terms, artificial intelligence? See, what should happen? Why? How will the machine learn? It will learn through the statistical analysis of data which it keeps on continually gathering. Okay, it will learn from statistical analysis of data which it keeps continually gathering through various processes on it. Okay, it could be the information about some things. You have seen something as a recommendation engine. So have you searched books on Amazon, let's say? Have you searched books on Amazon? So what does it do? When you say click a book, when you give particular input, let's say I'm giving math, and I'm giving this book, Analytic Geometry by Thomas and Hill. Then what will it do? It will show me 10 other books on the same topic, very similar kind of syllabus. Okay, it will show me these books. So there are books like Stewart and all that which will come into this thing. So what is it? What is going on at the background? What is going on at the background? See, this has on displays all kinds of things, index of the book, the fixed covers, all those things are stored somewhere in the database in such a way that suppose Thomas Finney starts with a list of topics, and then there are other books which have at least 80% of the topics common with Thomas Finney. Those books are also okay. So what it which is going on behind the scene? What does the recommender engine do? It keeps on categorizing things, then it will come up with even the idea will just what Thomas Finney, and then very likely to look into maybe there are say 20, 30 things which by that or whatever the engine learn that out of these 40 books, these 10 are more frequently. Okay, so now question is that what is my role in this? What I am supposed to do? If I want to say that I want to do machine learning, I want to do this. So what I am supposed to do? I am supposed to, as every computer science student or scientific computing student, what I'm going to do is that you are going to modify correction engines. Must have knowledge of statistics and means that is mathematics. Okay, people ask this question that why computer science people need this, need that, need that. But you need everything because computer science it is very much an applied subject. Computer is a machine which is not built to do a specific job. If the job it does is something like a good sorting, it doesn't do anything else. Okay, you it cannot be modified to, but when the automobile is built in for the profit is that it is not built to do a specific task. It it is very difficult to find anything in which computers are not applied. In which computers are not applied. See, traditionally there used to be certain areas where only humans will work, something like surgery. But now there are even robot guided surgery. So there is no is applied. How did we achieve this? How did we achieve this? Because we made the computer to do the work we want. Okay, so what is your job? You are not going to treat computer as black box. That's something it's given some output comes. You should exactly know why that output comes, how that output comes, in what way I can modify this black box so that I get the right output, the one which I desire. So if I want, I should know exactly how machine works, how to make machine work the way I want. So when you go for this machine learning, it doesn't have so you want to do okay. So please first ever Secondly, you are going to do it in such a way that you are getting okay. So look at it as a tool, and that will throughout. So one of the so when we want to use mathematics as a tool, what do we want to start with? First, we should we should have various quantities around us in a mathematical way. Various measurable, non-measurable quantities around us in a mathematical way. So I have a, let's say, I have set of students in your batch who has entered new in the department. What will be the things associated with the set of students? Several things, your BSc marks, entrance marks, then your anything, it can be home address, everything. So in case of the terms of the basis, what do? We have a primary key which can be a roll number. Okay, and then once I keep a roll number, I should all these things in place. Name of the student, marks in USC, marks in entrance, home address, all these things. So this you talk in terms of databases. But what we do another set, what do we call it? We call it a function. Okay, we call it a function. So function. So what is a function? The definition, mathematical definition, it is a mapping from one set to another. Okay. So let's say the first set is D and the second one is R, and this is a mapping. Elements of D are associated with the elements of R. What is this set D called? It is called domain, and this R is called range. Okay. So domain could be the set of students, set of anything else. The set so this domain could be set of numbers, set of objects, set of matrices, set of anything. And the range also, again you can have any variety also. But we are going to work with as domain and range or set matrices, angles, etc. Okay. And we working with set of numbers or objects like matrices, etc. So it is a mapping from D to R into range. The set from which the mapping we consider is a domain, and the other set anything x square, etc. So in general, x raised to n, the simplest thing. X square. So if you extend this concept a little bit, we have what is called as polynomial functions. What is meant by polynomial functions? The function of this type. Okay, polynomial functions, they are type. See this molecular functions x square, x raised to n, they are called monomials. X and a linear combination of monomials makes polynomial. Okay, a linear combination of monomials makes a polynomial. So you know several polynomials. Examples of polynomials: P1x, P1x, and any number of them you can construct. So this is polynomial function, and something which you are very familiar with. This is the simplest function you might have ever come across. Then you are type of function, another type of function. Trigonometric functions. So what are they? They all these functions, three functions, they are reciprocals, and then again powers combinations of them. Okay, so these are trigonometric functions which you are familiar with. What is the peculiarity of x and cos x? What kind of functions they are? Yeah, they are periodic functions. Wave function, true. But what we say in mathematical terms is that periodic function. And what is a periodic function? It repeats its value after a certain interval. So f of x plus say 2l is equal to f of x. This 2l is called period. Period, the interval after which it repeats its values. And you know, for sin x, or cos x, what is the period? They are 2 pi periodic functions. 2 pi periodic functions. Okay. Any other kind of functions you can think of which you know very well? Yeah. Is there any other class of functions which you know? Hmm. What about this exponential function? Say e raised to x or logarithmic function. You know them? What is the peculiarity of e raised to x? As x increases, what happens to e raised to x? It increases very, very fast. It increases very, very fast. So these exponential and logarithmic functions, they are of different category than this trigonometric polynomial functions. There are functions like this. You can have, say, something like a step function. What is a section? Do you know about this? Hmm? It's not continuous, it keeps on increasing in steps. So if I plot the graph of it, it may look something like this, that it increases in steps. Okay. And there are many more. Here, look at them, one by one. Class by class, of course. So let us talk about the polynomial function. Let us talk about the polynomial function. So what do we know about this simple class of functions? Say if x is equal to okay. If x is equal to x raised to 2n and gx is equal to x raised to 2n plus 1. So let's first take, let's say f1x is equal to x square. What is the peculiarity of this function? We can define it. See, this denotes the set of real numbers. Okay. We can define f1 R to R. But what can you say about square real number? Positive. So x square f1x, which is equal to x square, is always greater than or equal to 0. Even if there is a negative number, it is always greater than or equal to 0. So that brings us to one more concept. What is that concept? We are going to look at what is called as one function, and the second thing is onto function. What is meant by one function? That every point in domain D has a distinct image in. Okay, so one function means x1 not equal to x2 will imply f of x1 okay x1 not equal to x2 f of x1 is not equal to f of x2. Okay, and then onto function. What is this onto function? Onto function means for every by R there is an image or pre-image. What can I say? There is x in D. There is an x in D such that f of x is equal to y. F of x is equal to y. So every point in R has a pre-image in D. That is what onto function. So let's take this function x square for these two properties. These two properties. Okay. Whether the function is 1, 1 or not, whether the function is 1, 2 or not. So what happens if I take x1 not equal to x2? Will it imply will this happen? Are you sure it happen? This oh, there it is. There it is. What is the square of plus 2 and plus 2? It is same because you use the sign when you square. Okay. So this function x square f1x is equal to x square is not 1, 1. Is not. But what happens if I take, say, g1x is equal to x cube? Then what happens with the 2 of minus 2? It is minus 8. With plus 2, it is plus 8. So this function g1x is equal to x cube is 1, 1. But f1x is equal to x square is not 1. Okay, f1x is equal to x square is not 1, 1. So I think I'll rub this board. So this is a 1, 1 function, but this is not 1 function. Now, what about the second part? Is this function onto? If I treat this function f1x, f1 from R to R, will it be 2? It will certainly not be R2 because negative numbers don't have real square roots. They have complex square roots. Okay, they do not have real roots. So R to R, the function f1 from R to R is not onto. Okay, but if we consider this function f1 from R to R plus, that have a square root. So this function when treated as f1 from R to R plus is onto. What can you say about G1? It has a unique as unique root. So this function is not only 1 1, but it is onto. Okay, it is onto. So what can we say? Why did I call them fx and gx? What is the difference in them? Is that if you consider all the functions in that class, see if you consider this class fx to be x raised to 2n, then all greater than or equal to 0, because x raised to 4, x raised to 6, 8, any even power you take, it is always going to be positive. And if you take these functions gx, which is x raised to 2n plus 1, they follow the similar pattern as x cube. Okay, they are this class of functions 2n plus 1, they take positive and negative values because cube will be negative, fifth power will be negative for numbers. If the number is negative, its cube or any odd power will be negative. If the number is positive, its any power will be positive. Okay, so because of that, this class of functions, it in some way behaves similar to x cube. Okay, so this fx is equal to x raised to 2n. These functions f from R to R plus R onto, but not 1 1. Now this class of functions g, which is gx is equal to x raised to 2n plus 1. So this functions g from R to R are 1 1 and onto. Okay. So that true about this particular class of functions, that is this monomial to n plus 1. Okay. Now there is going to be a small homework for you. Plot the graphs of x, x square, x cube, 6 for minus 2 less than or equal to x, on the same graph. Okay, plot these curves on the same graph. X, x square, x cube, x raised to 4, x raised to 6, x raised to 5 and x raised to 6. 6 of them. Okay. 3 odd functions, 3 even functions. In fact, here we can introduce this concept of odd and even function also. What is odd function and what is even function? X square is even function. X or x cube is odd function. So what is it? Odd function means f of minus x is equal to minus fx. And even function means f of minus x is same as f of x. Okay. F of minus x is same as f of x. So what are even functions? Example, x raised to 2n. Here, example, x raised to 2n plus 1. Amongst trigonometric functions, which is odd function is even function? Amongst trigonometric functions, which is odd, which is even? Can you tell me the answer? Which is odd function, which is even function? Can you imagine the graph of sin x from minus pi to pi and cos x from minus pi to pi? Just do the work. Sin x is odd function while cos x is even function in that range. Okay. So I think I'll stop here with that homework, and homework is going to be a regular feature. Okay. Yeah. So you will get the link of the next lecture on the group, isn't it? On their email. Yeah. On your email. You will get the link for the next lecture on your email, which will start very soon, within 10 minutes. Okay. Okay, so we stop here and continue on Monday. So till Monday, you are going to do this homework. Okay.